Okay, so welcome back, and in this example we're going to find the area under the area of a region under a curve. The only difference is the function that we're dealing with is this. So we want to find the area under this function over this interval. So I just sketched a graph. So I just did a quick sketch of the graph. Again, you just want to see what it looks like. So this is a square root, right? So it's a square root function. And it's x squared minus 9. So it looks something like this, right? So it curves this way, and it's going from 3 to 5, and here's the region, okay? So we just want to find that area. So pretty straightforward, but we've got this to contend with. So really, I mean, it's just finding the area. So we're just going to integrate the function over this interval. So we're going to go from 3 to 5, and we're just going to integrate this. But we can't do it the way it looks because we don't have any tools. Well, yes we do. We do now. Normally we wouldn't, but now we can use trig substitution. And so it's in the form, right, that we're going to use secant. Sorry. So here's the idea. No, let me leave it up there. So we're going to use secant. Right, so x equals, well, here a is 3, right? So a is 3, so this is going to be 3 secant theta. And then, of course, dx is going to equal 3 secant theta tangent theta d theta, right? Okay, good. Now, if we do that substitution, we also have to change our limits of integration. So 3, if x is 3, well, this is 3 here, so that means that theta would have to be 0, because then the secant of 0 is 1, and that'll do it. So this would have to be 0. And then if x is 5, well, that's going to be a little bit trickier, so let me just write it out here. So if x equals 5, then we get 5 equals 3 secant theta, and so we get secant theta equals 5/3. And so in this case, we're just going to have to solve. Yeah, in this case, we're just going to have to solve for theta. And so we get secant inverse of 5/3. So that's what we're going to have to put. I know it's a little messy, but, oh, hold on a second. 3 to 5. So let's do that. So we're going to change. We're going to change our limits of integration. We're going to change our limits from 0 to this. Okay. So that means this is going to become the integral from 0 to secant inverse of 5/3. And this is going to become the integral of, now it's going to be 3 secant theta squared minus 9. Okay? And then we're going to get dx, which is 3 secant theta tangent theta d theta. Okay. Looks kind of messy. So let's simplify this. I'm not going to keep writing these limits of integration just to save time. So again, just realize that these are the limits of integration. We'll come back to that. So then this is going to become 3 squared, which is 9, secant squared theta minus 9, and we get 3 secant theta tangent theta d theta. Now, if we factor out the 9, we're going to get 9 times secant squared theta minus 1. And of course, this is just going to be what? This is just going to turn into 3. Oops. Oh, let's go one more. Yeah, let's go one more. This is going to be 3. So we end up carrying that away, right? Now, this here is just tangent theta. So we get the square root of 9, tangent squared theta. Tangent squared theta. And we get, let's pull the 3 out. So we get 3 there. And we get secant theta tangent theta d theta. And now this just reduces to 3 tangent theta. And so since we're on the interval, right? So a is 3, right? A is 3. X goes from 3 to 5. So a is greater than or equal to, x is greater than or equal to a. Okay? So that's important to know because then this is going to be positive. So we can drop the absolute value signs. We don't have to worry about taking the opposite value. So this is going to be, 3. So this is going to be 3. So we're going to pull the 3 out. So this is going to become 9 times the integral of tangent theta, which is going to become tangent squared theta because of this tangent, and then we get tangent squared theta secant theta d theta. Okay, we've seen this before. So in this case here, we're going to use the identity to change this to secant squared, right? So this is going to equal 9 times the integral of what? Secant squared theta minus 1. Oops. Times secant theta d theta, right? And now this becomes 9 times the integral of secant cubed theta minus secant theta d theta. Now again, remember the limits of integration are still 0 to secant inverse of 5/3. Okay, so now let's give us some more room. I'm going to erase this. Okay, so this is where we're at. And so now we've got to integrate this. And again, you should remember how to integrate this. And so you got to be careful. So remember, you have to do this one by integration by parts. Okay, so this is going to give us 9. And so the integral of secant cubed theta Okay, so that's the first part. So that's this part here. And then, oh no. Yeah. Okay. And then we got the first part. Okay. So remember, we did this twice. So you have to do integration by parts twice, and remember there's a half because you have to divide by 2. So you get this. And then you're going to subtract. Yeah, that's what I want to do. You know what, let me get rid of this. We don't need this anymore. And then you're going to subtract the integral of this, which is, again, you should know this one. It's going to be the natural log of the same thing here, right? It's going to be the same thing here. Secant theta plus, oh, let me rewrite that. So minus and this is going to go from 0 to secant inverse of 5/3. Okay, so now, okay, now we have to simplify this thing. Okay. So notice here, we've got a half here, and we're subtracting off a whole here. So that means we're going to get a negative half, right? So we've got the same thing here and the same thing here. We've got subtraction. So we're going to end up with the same thing, but it's going to be negative a half. Okay, so I'm going to rewrite this as 9 times, and I'm going to put this as 1/2 secant theta tangent theta minus 1/2 the natural log of the absolute value of secant theta plus tangent theta. And this is going to evaluate it from 0 to, again, secant inverse of 5/3. Okay? Okay. Now, okay, now we're we're going to evaluate this thing. Okay, so let's start with 0, see how things simplify. So again, this is going to be 0. Tangent of 0 is 0. Okay. Cosine of 0 is 1. So the reciprocal of that is 1. So secant of secant of 0 is 1. So the natural log of 1 is 0. So this whole thing goes to 0. And then of course this whole thing goes to 0 because tangent theta is 0, secant theta is 1. So we get 0. So good. We don't have to worry about 0 here. So all we have to do is put in secant inverse of 5/3. Well, if we do that, what happens here? We get 9. So all we're going to do is evaluate its secant inverse. Well, secant inverse of theta, secant inverse of 5/3 gives us 5/3 here. Okay? So far, so good. Now, here's where we have to look at our triangle here for a second. So let's look at the right triangle. Well, we know, right, so again, we know secant theta is equal to 5/3. Well, what's secant? Well, 1 over cosine. So if secant is 5/3, then cosine is 3/5. And so we know that this is going to be here, like so. Because cosine of theta is adjacent over hypotenuse. Well, this becomes a 3, 4, 5 triangle. And we all, at this stage, should understand that that is a special right triangle. Right? So as soon as you see this is 3 and this is 5, this has to be 4. You could use the Pythagorean theorem, and in fact, in general, that's what you would have to do. But this makes it easy, because now, I know what tangent theta is. Right? Normally, we would have to do what? We'd have to do the tangent of the secant inverse of 5/3, right? But we'd still have to draw a triangle and figure out what it is. But again, if you just reason through it, you know that tangent of theta, well, if you do your triangle, you can figure out all the 4 sides, and then you just do your ratios. So tangent theta is what? Opposite over adjacent, so this is 4/3. Easy. Okay? Remember, that's why you want to know your reference triangle. Okay? Now, let's do minus 1/2 times the natural log of the absolute value. Now, again, secant theta, we already know, it's 5/3. Minus tangent of theta, well, we already know that. It's 4/3. Oops. Okay, so this is not bad. So, now, this is going to be 1/3. So we can drop the absolute value sign. Sorry. Ugh. Okay. So now, this is going to be 9. And this simplifies to Well, nothing, oh yeah, this cancels out. So this becomes 10/9 minus 1/2 the natural log of 1/3. And so now if I distribute the 9, what do I get? I get 10, right? I get 10 minus 9/2 times the natural log of 1/3, and that is the exact area in square units for the region described. Hold on. Oh, that's, hold on a second here. Oh, I made a mistake. Plus. Not minus. Gotta watch out for those sign errors. So this becomes 3. Yep. Okay. So you get 9/3, which is 3. Okay. Oh, so this is 3. And that's it. So again, make sure you watch out for those sign errors. We all make them sometimes. Okay, that's it. Take care.